So folks, in this video we're going to look at piecewise functions, which you've likely seen before, but this should be a good review. So a piecewise function is sort of as the name sounds, we break up, and this is the key part, we break up the domain of the function into pieces. Now one of the things that's always been a little bit confusing, I think, about piecewise functions is that the broken up domain is stated before the function rule. So we have, for example, the domain of this function would be all of these little segments, or these separate domains, and to decide which of the function rules we use, we always look at the domain components and decide which of these end domain components applies here, and then decide the rule. So it might be that if I give you an x value in domain 2, then you're going to use this rule right here. But if the x value that I give is in this domain, then you're going to use this rule right here. And that's one of the confusing things about the piecewise function. So we're going to go ahead and practice that down below here. So here I've given you the graph of a piecewise function, and we will get some of the information from the graph, but I want to warn you that we're not just getting all of this information from the graph. What I want you to learn, and the skill that I'm going to assess you on, is your ability to apply your knowledge of piecewise functions without necessarily being given the graph. Okay? So this is our piecewise function. It's called p of x. Notice there's p of x. But what we can see is that I've broken this, this function is broken up into three different places, and we're going to assign domains to each of these separate function rules. So for example, if I were to look at the domain of this first piece, the domain of this first piece would be this interval right here. I'm going to put an open green dot right there. This would be the domain of that first piece. And so notice that this holds for x values between -7 and that looks like -4. Because we don't actually include this point in the function right here, we're not on this portion of the graph, we would say that that's strictly less than -4. Okay, so then for this second piece, here, this is this line right here. This is the line 3/2 x plus 5, and you've been doing a review of lines. You can see that the y-intercept is 5. You can see that the slope of this line, if we go to the right, 1, 2, 3, and up 1, 2, 3, 4, 5. If we go to the, let's take this point, if we go to the right, 2, 1, 2, and then up 1, 2, 3, then we arrive at another point on the graph. The domain of, or this particular piece then, is this graph right here. But the question is the domain of this function isn't all real numbers of this piece. Which numbers do I use when I want to construct this graph in the domain? And the answer is I'm going to take these values between here and here. So in this case, the domain of the second piece would be from -4, and this would be less than or equal to, because we are including, for this point right here, we're including that endpoint, less than or equal to x, and that will be less than 1. There's the domain of that second piece. For the domain of the third piece, this is our third piece here. This is the horizontal line. You could think of it as the horizontal line, y equals -4. There's this horizontal line. And what I'd like to do here is, you don't need to do this. I'm going to sketch the entire horizontal line, y equals -4. But I only want that horizontal line to show up for x values in this interval right here. So for these x values in this interval. So the domain of this third piece only applies for x values between 4 and infinity, or we could say 4 is less than x. If you were to write less than infinity, that's okay. I won't always be consistent in the way I do that. Okay, so before I give the domain and range of this function, which are two great questions to ask, let's go ahead and just practice evaluating the piecewise function. Now, this is going to be a little bit challenging for you, I know, because I've sort of cheated, and I've given you the graph of this function. What I'd like you to do instead, and this is kind of challenging, I want you to suspend disbelief. I want you to pretend that graph isn't there, and I just want to look at this piece of the function right here, or just the piecewise function, the description that I've given you right here. Okay. So what I'd like to do here is, without using the graph, and this is what I need you to be able to do. So I know that you've got the graph, but without using the graph, we want to evaluate p of -6. So let's go look up here, because I have these three separate function rules. we've got three different rules. Maybe I'll take x and just return the number -4. Or maybe I'll take x and plug it into this expression here. Or maybe I'll take x and plug it into this expression here. The question is which of those three rules applies in our case right here? Okay. Well, what we're going to do is we're going to identify that the domain value that we want to evaluate this is at x equals -6. And which of these three rules apply? So pause the video, decide which of those three rules apply. So the rule that applies is this green rule right here. This one, let me go ahead and underline that in green. This green rule right here, oops, that should have been a green color. This green rule right here applies because my x value is inside of this interval. So when it's time to evaluate this function, we're going to say that that's equal to -2x, and I don't remember what the y-intercept was, minus 11. And folks, I have an error here. I wanted to write -2 times that x coordinate, which is -6 minus 11. That gives me 12 minus 11, which is equal to 1. So what is p of -6? It's equal to 1. And you can verify this now on the graph, that when we plug in the domain value -6, we get out the y value, +1. But what I'm more interested in is deciding which of these three rules, Rule 1 underlined in green there, or Rule 2 underlined in red there, or Rule 3 underlined in blue there, which of those three rules applied given our domain value -6? And the answer is to look at these three different domain restrictions and decide which of these does our domain value fall into. By the way, a good question might be, what if it fell into two different intervals? But the thing is that this graph actually is, this function here actually is a function, truly indeed a function. And so you can't get two different intervals for which our domain value applies. Okay, so let's try another one here. Let's go ahead and evaluate p of 0. Okay, so we want to evaluate p of 0. So we look up here and we decide which of these three rules does the x-coordinate 0 fall into. So pause the video and answer that question. Which of the three rules am I going to use? Green, red, or blue when my domain value is 0? So the answer is we're going to use the red rule, the second rule. How come? Because 0 is inside of this interval here. It's not inside of this interval, nor is it in this one. So we're going to use the red interval there. And so we will take, to find p of 0, we're going to go ahead and say that that's equal to, and I forget what the slope is, 3/2 times 0 plus 5. So notice what's different here. When I evaluated the domain value at -6, I used one rule, but when I evaluated the domain value at 0, I used a different rule. This simplifies to be 3, so we get that p of 0 equals 3, and that doesn't, I'm sorry folks, I miscopied, I couldn't read my own handwriting. This should be a 5 here, which would then make this a 5, my apologies. And that fits, you'll notice, with the graph there. Okay, so let's do this next value. Let's go ahead and do p of -4. So here we got to be a little bit more careful. We're going to evaluate p of -4. We're going to look back up at our three different rules and decide which of these rules applies. Well, careful, I'm not looking at the rules themselves, I'm looking at the domain segments. Remember, that's what we said. We're going to break this up into these different domain segments, and we decide for each x-coordinate which domain segment does that x-coordinate fall into. So let's be a little careful here. When we pick the domain value -4, I'm looking up here and I see, oh, this says x between -7 and -4. But this says x between -4 and 1. Which one am I going to use? I'm going to use the red interval because x is allowed to equal -4 in this red interval, where this says that x needs to be strictly less than -4 in the green interval. Okay? So evaluating p of -4, we're going to plug it in the value -4 into that same red function as we did in part 2 there. So we get -3/2 times -4 plus 5. Cleaning this up, we end up, let's see here, -3/2 times -4, that would be -2, -6 plus 5, and that comes out to be a value of -1. And sure enough, that matches with the graph there. And in fact, when you look on the graph, you see where the sticky issue was. We were deciding which of the two rules applied for the domain value x equals -4, but that was clarified in our rule of assignment for the segmented domain up here, that we wanted to use the red rule because our x-coordinate fell in the red interval. Okay? So finally, folks, let's go ahead and evaluate, or try to evaluate, P of 3. And actually, I love working with piecewise functions here because it gets to the idea of what we really mean when we say the functional value is undefined. Because if I go look up here, notice that P of 3 does not fit into this interval. 3 does not fit into that inequality right there. Nor does 3 fit into that inequality there, and nor does 3 fit into that inequality there. So we're going to say that P of 3 is undefined. Okay, so now we want to look at the opposite question here, folks. In the previous question I asked, say, for example, what happens if the input into this function is -6. So we inputted in -6, and we found that the output was 1. This is the different question. In this question, I'm saying I know the output needs to be 4, and I'm asking you what input will give me an output of 4. So what I'd like to do here is we're going to cheat a little bit. We're going to decide which piece applies with the graph, but we're going to go look at where is the output of this function equal to 4. And if I go look at the graph of this function, if I were to trace a horizontal line right here, that's not a perfect line. I'm not going to get it great, but let's try that again. If I were to trace a line right on here, this is where the output value, the y-coordinate, is 4. And we see that the y-coordinate is 4 at this point on our function. And there may be other points, but that's the only one we've got in this case. So this is the second piece of our piecewise function. So what I'm going to do here is I'm going to take our piecewise function and I'm going to set the second piece to force the output to be 4. So let's go ahead and do that. I'm going to go ahead and write set p of x equal to 4, and then this is the part that I need to see from you. We select the correct piece. This happens when 3/2 x plus 5 is equal to 4, which happens when 3/2 x is equal to -1, or finishing out solving for x, this happens when x is equal to -2/3. Okay, so I am interested in finding this value here, but it's very important to me that you think about it from the perspective of setting the output of the piece that applied equal to whatever that output's supposed to be. So here, I didn't set all 3 of these pieces equal to the output of 4, because only one of those 3 pieces intersected the line y equals 4, and that was the middle piece. That's what I've set equal to 4. Okay, let's try that again here, folks. In this next problem, we're asked to solve p of x is equal to 2, so let's give that a shot. Well, if I were to draw a horizontal line here at y equals 2, you don't need to draw that. The drawing might get a little cluttered. But if I were to draw a horizontal line right here at y equals 2, I see that this horizontal line intersects the graph in 2 different locations when it intersects the first piece and the second piece there. So what I'm going to do is I'm going to have to do this twice. First, we'll set, in setting p of x equal to 2, we're going to set the first piece equal to 2, which was -2x minus 11, and we're going to set that equal to 2, and we'll solve that equation. That happens when -2x is equal to adding over 11 equals 13, or when x is equal to -13/2. Remember, that's about -6.5, and sure enough, we can see that this first piece of the graph intersects the line y equals 2 at about -6.5. And we found that by setting the first piece of the graph equal to 2. Okay, but that's only one of those 2 intersection points. The other place where our horizontal line at y equals 2 intersected the graph was in this second piece of the graph. So I'm going to set 3/2 x plus 5 equal to negative 2 to go find that location. So when we do that, we have 3/2 x plus 5 needs to equal 2. That happens when 3/2 x is equal to, subtracting over the 5, negative 3, or multiplying both sides by 2/3, we have that happens when x is equal to negative 3 times 2/3, or when x is equal to negative 2. And notice if we go look at the graph of this function, when x is negative 2, we find that the output value is indeed the positive 2 that we were after. So I used the graph to help me decide which of the two pieces, or which of the different pieces in the piecewise function I should set equal to the rule of assignment here. Okay. This next one, I'm just going to go ahead and give the answer to. What input values give me output values of negative 4? Well, look at, there's a whole bunch of them. They're all along this horizontal line here. Every single input value from this blue shaded region on gives me an output of negative 4. And so the answer to that question is for all x contained in the interval from negative 4 to infinity. Careful, notice I did not include that endpoint there because we don't include that domain value in the actual domain of the function. Okay. Lastly, let's go ahead and solve p of x is equal to 5. And if I were to do that, if we were to go solve p of x is equal to 5, that happens when the first piece of the function is equal to 5, or sorry, the second piece of the function, this second piece of the function, which I've underlined in red here, that's where the graph has an output value of 5. And so if we were to do that, we could see that happens at x is equal to 0. For the input value 0, we see that we output a 5. Okay,